A smart home is a home that has had its home systems integrated together into a central processing hub. The home systems could include things such as temperature, appliances, intruder detection, lights, and any other internet-connected system in the house. The goal of this project is to design the hub and the systems it controls using various electrical circuits, software controls, and an Android app to control it all. We were able to accomplish this through embedded system design and circuit analysis.
This type of project has the potential to be a large part of the world in the future, as many devices begin to integrate the Internet of Things into their designs. With this in mind, it becomes ever more important that these systems are designed efficiently and conveniently. Because of this importance, this project is extremely interesting and fun to work on.
There are two main facets to develop in this project: the hardware side that will interact with the world, and the software side that will be the controls of the systems.
Now, in regards to our specific projects, hardware circuits, a lot of our systems are currently not completely integrated yet. This is evident by sort of the breadboard being sectioned off into different parts. For example, over here we have all of the audio amplifier circuit built, and here we have the nightlight situation, and here we have our button. But that's not to say that our individual circuits are going to be not going to be integrated, and we do have something to show for that. But in terms of individualizing all of them, we're going to start by looking at the audio amplifier circuit. The schematic is shown on screen right now, and all the values were given to us by the data sheet for our specific audio amplifier, which was the 386D JRC. However, one thing of note is that we had to choose an arbitrary but not completely randomly chosen bypass capacitor, and that's shown here by this capacitor. Basically what it does is it just filters out all the noise so that when we are using other parts of our circuit, the audio amplifier and the speaker connected to it, shown right here, does not display static noise. And so that's what this bypass capacitor does, and it's not given to us by the schematic. One thing of note is that I have a 10K potentiometer right here, and we have that so that we are able to choose what volume that the audio amplifier plays at. And right now we have it set at a current good listening level for the average human ear to listen to, at least within a close range. And so basically, using the power of our Arduino and this code that I wrote, which should be on the screen right now as well. What I can do is I can use our given push button, which was biased with a pull down resistor here, giving it power, and using the code I can let it pass through a high voltage into the Arduino, which will let me have a catch in the code that allows me to play the audio amplifier circuit. Now, once again, this was chosen, the values for our tone, our frequency, and the volume were chosen by us. However, we believe that now that everything is working, we believe it'll be a good intruder alert system. So here we go. Following that, we have the circuit for the nightlight, and this is a pretty simple circuit, and I have the code that I've written for it displaying on screen now. Essentially what it's doing is taking the variable resistance from the photovoltaic cell that was given to us in our kits, and it's comparing the daylight values with the nighttime values, and when it detects a nighttime value, it ends up giving a high voltage and powering on an LED. And we have the sensitivity turned up for demonstration purposes currently, but this is what it does.
Continuing with the necessary hardware implementations for this project, we've developed two more circuits to show you: the LCD screen here on the left, and the all-important Bluetooth module here on the right. As you can see from the schematic shown on screen now, most of the wires connecting to the LCD screen are data wires connecting to the Arduino, with the exception of the potentiometer here and the resistor here. The potentiometer controls the contrast of the screen, making it either higher or much lower. The resistor controls the backlighting of the screen, and without it, it would just show the words with very little contrast to be spoken of. The all-important Bluetooth module on the right has simply 4 wires, one for power, one for ground, and then 2 connecting to the Arduino here to send data back and forth. The code for these 2 is much more in-depth, and we will spend a bit longer going over it now. We will begin by discussing the Android app component of the Bluetooth software. As you can see on screen, this is a picture of the MIT App Inventor and the GUI we've developed for our Android app. It's fairly simple as of now, and it will continue to increase in complexity as we add features to the system. Right now, there's a Bluetooth Connect button at the very top, which is the first thing you have to press, as if you press anything else beforehand and it's not connected, it will not allow you to do anything. Once you press it, you can connect to the correct device. Once you've connected, the connection status will change to connected, and you can use any of the other buttons. The LED on and off button control the LED on screen on the Arduino board, and they show a message on the LCD screen. The send message button and the message box is a system we're currently developing that will, when correctly working, display the message you write in the box on the LCD screen. If we look at the software for the Android app, we can see that it is developed using this block style system. On the upper left, you can see the Bluetooth connection, and this is what allows you to connect your device to the Bluetooth module. You can also see where the disconnect button is programmed in. This will simply disconnect your device. On the upper right, you can see the LED on and off buttons. When they're clicked, and seeing if the device is connected, it will send a 1 byte character to the Bluetooth module. This is the system we are using to develop the software, as it is easiest for the Arduino to understand single bytes of information coming from the serial monitor that the Bluetooth module is communicating with. And we also see on there that if it's not connected, it will send a message first saying please connect to Bluetooth. In the bottom left, you can see the send message. And this will, as long as the message box isn't empty, it will send the message you send surrounded by 2 delimiters, a 2 and a 9. And this is a system we've developed to display the correct message onto the screen. And of course, if there's nothing in the box, an alert will show up saying please enter a message. Now, communicating with this is done. Now processing this data is done on the Arduino side, and we will show you that next. The Arduino code for this project is the other main driving force behind making it work. Starting from the top, we include these 2 libraries. This one controls the LCD screen, and lets us write and print to it. This one adds an additional serial port to assist in communicating with the Bluetooth module. These 3 pins are defined as 2 for the Bluetooth module and 1 for just an LED. Making this 13 means we control the onboard LED on the Arduino just for testing purposes. These first 2 lines initialize these libraries and assign pins to them. So these pins are for the LCD, and these, which we defined above, are for the Bluetooth module. This is our incoming character value that we receive from the Bluetooth module, and it's what we base the majority of our code on. In setup, we simply begin the serial imports, set the LED pin to an output, and begin the LCD screen. These numbers dictate the size of the screen, so 16 digits wide, 2 down. In the loop, our main code begins. This first line makes sure that the Arduino has received some input from the serial port. If it has, this next line reads what it is and sets it to incoming value. This one prints it for debugging purposes, and these 2 main blocks of code are the simple logic that we have right now. As looking back at our Android app, you can see that if a Bluetooth, the LED on button is pushed, a 1 is sent, and if an LED off button is pushed, a 0 is sent. Based on this, we set the LED pin to high, turning the LED on, Clear the LED screen from the whatever it previously held, and print LED on. Do the same thing for LED off if it's 0. This can be expanded on to include new incoming values for new functionality, such as the 2 and 9 with the printing, although there is some complication with that, which we'll be working on in the future. What we have shown you today is what we've completed on our project at the current time. In the future, we plan on integrating more functionality into our LCD screen, such as showing temperature or maybe volume, as well as adding functionality to the Android app, such as maybe controlling the volume of the speaker or the value of the potentiometer with the Android app through the Arduino. We also need to finish the thermistor circuit to measure the temperature, as well as adding voice recognition to the app and tying everything together. Thank you for watching today. That's all.